I'm Kim McIntosh. I teach biology at Shadow Mountain High School in Phoenix, Arizona. And this presentation is about the methods of science. So let's start off with what is science? Well, science studies the natural world. It is focused on discovering knowledge and really figuring out how the rules of how things work in the natural world. So it deals with natural phenomena, natural causes, and it excludes the supernatural. So anything that cannot be tested is not necessarily considered science. So this is the study of biology, which is the study of life. It's in a category of life sciences, and as you can see from the list, there are quite a few different areas of life science that you can study, everything from plants to animals to disease and genetics. So biology is the study of living organisms and their interactions with their environment. So you can see here that biology includes plants, people, and different animals. So there are 7 properties of life, and this really is this is a list of things that we use to decide if something is living or not. So we have cellular organization, homeostasis, metabolism, responsiveness, reproduction, heredity, and growth. And I'm going to go through this list one at a time and explain a little bit about what each of these means. So the first one's cellular organization, and this just means that every living thing is made of cells, and those cells have specific organelles or things inside of them that do jobs that help keep the cell alive. And all cells come from previous cells, so it's not like there's any cell that just pops into existence. They have to be reproduced from a former cell. The next one is homeostasis. This is a fancy word that means maintaining the internal environment. So cells have to do this. There's small, very small fluctuations inside of the cell, but the cell has control systems and it will maintain its internal environment. There's also large external fluctuations. So say the temperature outside is rather hot, your body is going to respond to that to maintain your internal environment. Your body also has to maintain your hormone levels and your blood sugar levels. Metabolism is all of the chemical reactions that are required to help you obtain and use energy. So we know that all energy comes from the sun. Okay, so it all starts right here with the sun. Plants then use that energy to make their own energy. And then we, in turn, will eat those plants, or we will eat meat, which came from an animal that probably ate plants. If they didn't, if they're a carnivore, then eventually the chain goes back to the sun, because that's where all of is energy reacting to factors in the environment. So whether you're this bird up here in the corner that is in cold weather and so fluffs the feathers to keep themselves warm, or the plant down in the lower left corner where it's reaching towards the sunlight. Reproduction is making more of their own kind. So all living things do this, whether they are humans or cats, dogs. Plants have to reproduce. They have to make more of their own kind. Sponges in the ocean. All living things have to reproduce. And heredity is closely tied to reproduction because heredity is passing on traits from parents to offspring. So this is why oftentimes we see that the offspring looks a lot like the parent. The next one is growth. So all living organisms grow, and as they grow, they change, which is called development. All right, so let's talk a little bit about the scientific method. All right, this is the step-by-step process where we investigate a question. So we observe, we come up with a hypothesis, and perform experiments. But it goes in a process. So the first step is to state the problem or pose a question. The second step is to gather some information. Maybe somebody already knows this. Maybe we can just Google it and get the answer to it. If we can't find the information we're looking for, or we're not satisfied with that information, then we form a hypothesis, and this is a possible explanation or answer. Step 4 here is to test the hypothesis with an experiment. Experiments always have two variables. They have the independent variable, which is what you change, and they have the dependent variable, which is what you're going to measure when you perform the experiment. So good experiments have a control. This is something that you don't do anything to, so you want to use it to compare your results. And a classic experiment that's often referred to is the plant with fertilizer or without fertilizer. So this plant, this one was not provided fertilizer, and this one was provided fertilizer. So this would be our control. This is the one that we didn't do anything to, okay? Our independent variable would be fertilizer or no fertilizer, and our dependent variable is how does the plant respond to that? So we would measure the growth of the plant over time. The next step is to analyze the data. So we're going to organize the data into charts or graphs that can be read by people, so it makes it easier for people to look at our data. Now, this is a chart or a table, okay? And a lot of times we will make the table before we do the experiment so that we have a place to record information while we're doing the experiment and collecting our data. This here is a graph, and this is done after the experiment. So after we have all of that data, then we can put it into a graph form so that it's a visual and people can look at it and see easily what your results were. Step 6 is to form your conclusions. So here's where you're going to determine if your hypothesis is supported or rejected, okay? So if your hypothesis is not supported, that doesn't mean the experiment is a failure. That just means that you need to modify your hypothesis and try again and see if you can actually get to the answer. It's really a trial and error process. If the hypothesis is supported, we never really say that that proves that your hypothesis is right. We would say it's supported, and so you would repeat the experiment, or other people would repeat the experiment to see if they can come up with the same thing that you got. So here's the scientific method in action. Let's say you wanted to know the best material for insulation. And so you would investigate materials. You find out that there's wool, there's down, there's leather, and you would form a hypothesis, okay? So maybe you would say, well, I think that wool provides the best insulation. It would keep me the warmest. So you would design and conduct your experiment, and then after the experiment, you would analyze that data and you would draw conclusions. Were you right? Were you wrong? Maybe you need to test again. Scientists sometimes use models. We need models to help us visualize things that are going on. So think about the globe. Okay, if you're trying to find a city on Earth, or trying to visualize where is this city in comparison to where I'm at, a globe can be a great model to use, because otherwise you're just trying to do it in your imagination, and sometimes that doesn't work as well for us. And then we have a theory. A theory is why something happens, and it has to come from many observations and many experiments. It can change over time with new data, but a theory is always based on a lot of experiments. Okay, so we have germ theory, we have the theory of evolution. There's a lot of different data that goes into those theories. And then there's a law, and that tells you what happens. It's like a rule of nature. So we have the law of gravity, and we have the law of thermodynamics. Those don't necessarily change. We're pretty secure and confident that the law of gravity is going to hold true. And then we have technology. Technology is the application of science in ways that will help us. So a lot of times we think about this as computers, but it is also things like Velcro or steel. And I'm sure that you can think of a lot of other technologies that help us in our everyday lives. And that is the end of that.